let's say, for example, we drew a number line starting from, let's say this is a number line, and I have my 0 here. Maybe I'll say 1, 2, continuing, maybe 3, and here there will be -1, -2, and -3 like this. So you notice that if numbers are being more positive, they're going to increase going this direction. So you see the numbers get more positive as they go to the right. And you also notice that numbers as they go to the left, the number line, they get less negative. Okay. So they get negative as we go to the left, and they get more positive as we go to the right. So notice that even though in numerical value, this 2 is smaller than the 3, yet in actual value, -2 would be greater than -3 because values increase in value as we move to the right. So values get more positive as we go to the right. All right. So we shall keep this as brief as possible. So we're going to look at a few examples where we're going to be working with these problems. So let's try out the first problems. Right. So let's start with basic addition. Let's start with basic addition. Let's say we have an example like this one. 3 plus minus 6. Okay. So what we will do is we're going to draw a line. We want to solve that problem. 3 plus minus 6. So I'm going to write the problem here on top. All right. 3 plus minus 6. So again, I'm going to draw my number line like this one. 0, 1, 2, 3, 4, -1, -2, -3, -4. All right. So we're starting here at +3. So if we're adding a negative number, it means that we're going to move how many places? 6 places to the left, because this sign here tells us that the 6, then we're adding 6 places going to the left. Like we said that when numbers have got a negative sign, it means that they are getting more negative as they will be moving to the left. So adding a negative number means that we're going to move 6 places to the left. So that will be 1, 2, 3, 4, 5, 6. So you can see here 3 plus -6 will give us -3. Another way to explain this would be to use the concept of inverse. Okay, inverse. So when we talk about inverse, what we mean is um, the inverse of a number is subtracting it is the same as adding the inverse of a number. For example, if we say 3 minus 6, it will be the same as what we wrote here. It will be like 3 add the inverse of 6. So the inverse of +6 means that we're talking about the negative, and here we're going to move 6 places to the left like we did here. All right, so we shall not waste more time here. Let's move on. Right, so let's move on. Let's try another example. -3 plus -8. Again, this one is very simple. It is like the same as -3 -8. There are some mathematical rules which you should observe when you're working with integers. Let's say, for example, you find these two signs plus and minus together. What it means is if they are following each other like this, the overall effect would be negative. For example, if we have a problem like this, it is the same as saying -3 -8. All right. If you have minus and minus following each other, it means that the overall result is positive. All right. Let's say, for example, you had minus 2 minus minus 2. This would be the same as saying minus 2 plus 2. If you have minus and plus, it will be the same as this one. And if you have plus and plus, it will just be positive. No need for that. So like if we write it like this will give you again another negative. And if you have a positive and a positive, this would give you a positive. All right. So you must also appreciate these rules whenever doing your you are doing your additions and subtractions and anything uh, in our operating with integers. All right. So now we move on. Let's try some problems involving number pyramids. So there are these creatures called addition pyramids in mathematics. So let me make one here like this one, and here. Wait, I'll put some numbers here. I'll put 3 minus 5. So here I'll put a 3. Then I'll put a minus 5 here. Then here I'll put a 1. So the rule of working with these number pyramids is that when you're working with these number pyramids, what you should appreciate is the fact that these number pyramids are as a result of are built from the foundation or from the base going upwards. For example, in this example, we have 3 minus 5 and 1. So the number on top is built as a result of adding the two numbers below it. So we shall do the first one, 3. We shall add this 3 here and this 5 there so that we can be able to work them out. All right. So it will be 3. It will be 3, uh, 3 minus 5. All right. So I shall write it this side, 3, 3 minus 5. So this one is the same as saying 3 plus minus 5. So like we said, if we add a negative number, it will be the same as saying 3 minus 5. So 3 minus 5, it will give us minus 2. So we're going to write our minus 2 here. All right. And then for this next number on top of these two numbers, minus 5 plus 1. If we draw a number line, we just move one place to the right, and this would give us minus 4. So our minus 4 comes here. Again, to get the number on top here, it will be very simple. We just add this 2, minus 2 plus minus 4. So since we have these two numbers, these two signs plus and minus following each other, it will be the same as saying minus. And minus 2 minus 4 gives us minus 6. Why does it give us minus 6? It's because we are going to move 4 places to the left of this minus 2, which will give us a minus 6 like this. Okay, let's try another one which is not so obvious. Let's try another number pyramid which is not so obvious. All right. So say for example, you are given a number pyramid like this one, where like this, like this one, and then it'll be like this, and then okay, right. Let me change the color of this pen. Maybe put a more happier color. Let's hope green is happy. Right. So in this case now we have minus 7. We have minus 7 here. We're given the number on top, and then minus 6 here, and then 2 here. Now you can start anywhere you want. You can start here or you can start here. Anywhere you want, will get you the correct answers. So I'm going to start from the top going downwards. So we do know that this minus 7 is as a result of adding these two numbers. So we can try to formulate an equation. Minus 7 plus x. Oh no. Let's write it correctly. Minus 6 plus x is equals to minus 7. Okay. So according to the rules of algebra, if we want to remain with this x, we are going to have to add a positive number here so as to eliminate this minus 6 so that it gets to 0. So minus 6 plus 6 plus x equals to minus 7 plus 6. Then this one will give us a 0 and will remain with x equals to minus 7. And then we're going to add 6. So what it means, adding a positive 6 means that we're going to move 6 places to the right of minus 7, which will lead us to minus 1. So the number here would be minus 1. Okay. If we add minus 1 plus minus 6 will give us minus 7. And then this number here is as a result of, again, another algebraic equation which we are going to formulate. X plus 2 is equals to minus 6. All right, so this one is very simple. We're just going to subtract these 2 here. X plus 2 minus 2 equals to minus 6 plus minus 2. So this one will give us a 0. X is equals to minus 6 minus 2 equals to minus 8. So this number here is minus 8. And then the last one, we're going to write it this side. X, a missing number, minus 8, or x plus minus 8 is equals to minus 1. So we're going to add positive 8 both sides so as to eliminate this 8 here, equals to minus 1 plus 8. So x is the same as, we can rearrange this one, 8 minus 1, and then x is equals to 7. So here we'll need a 7, we'll put a 7 there. All right, so this is how you solve these problems with number pyramids. So if you have any questions, please feel free to let me know in the comments section. Don't hesitate, just let us know. Right, next we're going to move on to talk about multiples, factors, and primes. All right. So when we are talking about multiples, what we are saying is we are looking for the numbers into which a certain number can be divided into. What do we mean? For example, if I say the multiples of 6, I'm talking about all the numbers into which 6 can enter without leaving a remainder. All right. So for example, let's write our heading here, multiples. Okay. Multiples. All right. So let's look at how multiples work for this problem. All right. So for this problem, we're going to look at some issues here. So we say that multiples are problem which which are going to be a number into which a certain number can enter without leaving a remainder. So let's look at a few problems or concerning multiples. Let's look at a few problems concerning multiples. All right. Okay. So I'm just going to give you a few seconds to look at the multiples of, let's say, for example, multiples of 9, multiples of 12, and multiples of 15. Right, I'm just going to give you a few seconds to look at these multiples and tell us about these multiples. Okay, multiples. Can you just quickly find them out? And then we'll look at it. All right, so the multiples of 6 are 6 itself, 12, 18, 24, 30, 36, 42, then multiples of 9 and so forth. Let's just put 3 dots here, showing that the numbers continue up to positive infinity. The multiples of 9 include 9 itself, 18, 27, 36, 45, 54, 60, 3, and continues up to infinity. Multiples of 12, 12, 24, 36, 48, 60, 72, 84, 96, etc., etc. Multiples of 15 include 15 itself, 30, 45, 60, 75, 90, 105, etc. Right. So these are multiples. So you can see that already it is, we can also already introduce the concept of common multiples, where a common multiple is a number which is a multiple of two numbers. For example, if we were to look for common multiples of 6, I'll change my marker here. If we were to look for common multiples of 6 and 9, so if a question were to say, find the lowest common multiple of 6 and 9, this would be, so 6, we have a 6 here, we do not have a 6. We have a 12 here, we do not have a 12. We have an 18 and we have an 18. So the first common multiple would be the lowest common multiple. In this case, it would be 18. It would be very simple, right? Let's say, for example, another question says, find the lowest common multiple of 12 and 15. Again, we use the same technique. There's a 12 here, there's no 12. There's a 24 here, there's no 24. There's a 30 here, there's no 30. 36 here, no 30. 45 here, no 45. 48 here, no 48. 60 and 60. So the lowest common multiple of 12 and 15 would be 60. You can continue like this if you want. This one method. Of course, there's another method which we'll look at, of using indices, of using prime numbers or prime factors to find the common factors of any two numbers which you might have. Right. So let's try that. Let's move on to that, using expressing numbers as products of their prime factors. Expressing numbers expressing numbers products as products of prime factors. Okay, as products of prime factors. So firstly, you need to appreciate what a prime number is. You should know by now that a number is considered to be prime if it has no other factors except 1 and itself. So a prime number is only 1 and itself as the only factors. All right. So that's what a prime number is. So all numbers can be expressed as products of their prime factors. Okay. So for example, I have a number like let's say we were asked to find to express the number 60 as a product of its prime factors, as a product of its prime factors. Okay. So if 60 can be expressed as a product of its prime factors, what we can do is very simple. We write our 60 like this, 60. Then we divide by 2 until, or divide the lowest prime factor until the number is no longer divisible. For example, here we can divide by 2. This is the lowest prime number, which is a factor of 60. 2 into 60, we get a 30. We divide again the 30 by 2. 30 divided by 2, we get a 15. 2 is no longer a factor of 15. The next lowest prime number is 3. 3 into 15, 5. 3 is no longer a prime number, a prime factor of 5. So we divide by 5 itself, it's a prime number. So 5 into 5, 1. When we reach this stage, we've finished. So 60 can be expressed as a product of these numbers on this side here. So it will be 2 times 2 times 3 times 5. Okay. So 60 as a product of its prime factors is equals to 2 times 2 times 3 times 5. We can shorten this since we have 2 and 2. We can express this as indices, which will be 2 squared times 3 times 5, like this. Okay. Right, so this is how we express numbers as products of their prime factors. Now we want to see how we can find highest common factors and lowest common multiples using prime numbers or prime factors. Okay, right. So let's use this number 60. Let's use this number 60 as an example. Right. So find, maybe let's write this question. Find the lowest common multiple of let's say 12 and 15. Again, maybe a question can also say find HCF of 12 and 15. All right, let's say this one is part A, this one is part B. So to answer the first one, we need to express these two numbers as products of their prime factors. So 12 as a product of its prime factors can be written like this. We divide by the lowest or the smallest prime number, or which is a factor of 12. 2 into 12, 6. 2 into 6, 3. 3 into 3, 1. So 12 is equals to 2 times 2 times 3. Okay. And then 15 cannot be divided by 2, so we divide by 3. 3 into 15, 5. 5 into 5, 1. So 15 is equals to 3 times 5. Now, using these two expressions, we can come up with the lowest common multiple of these numbers and the highest common factor. So the lowest common multiple of 12 and 15 is found by taking the longest chain of factors. Okay, so here you can see that we have twos, threes, and fives. Okay, so the lowest common multiple would be taking the longest chain of twos. So we have it here. That will be 2. That will be 2 times 2. Then the longest chain of threes, both sides have got 1 3. So we just write that 1 3 like it is. The longest chain of 5 is found here. We only have 1 5 here, like this. So like this. So the lowest common multiple would be 2 times 2 times 3 times 5, which will give us 2 times 2, that's 4. 4 times 3, 12. 12 times 5, 60. we return to the same answer which we worked before. And then B, for finding the highest common factor, it's very simple. We just look at the factors here. We have a 2, there's no 2 here. There's another 2, there's no 2 here. There's a 3 this side, and there's a 3 that side. So highest common factor because we have a 3. Is there another common factor? No. So the highest common factor, 3. Very, very simple stuff. I hope it is easy to manipulate and no one can get lost. All right. So that is that for the highest common factor, lowest common and lowest common multiple. So this is how we find them. Now, we want to look at a few more examples. Want to look at a few more examples where we have problems like this. Okay. So I want to look at a few more examples where we have problems like this, and then move on to conclude our discussion or our revision on these numbers. All right. So let's say you have a question. Let's say you have a question like this one. Find the lowest common multiple of 7 and 11. Find the lowest common multiple 7 and 11. So the question is requiring us to find the lowest common multiple of 7 and 11. Right? That's very simple. We can just use our long method or our short method. Let's use our long method. Multiples of 7 equals 7, 14, 21, 28, 35, 42, 42 like this, 49, 56, 63, 70, 77. The next one will be 84, etc., etc. Multiples of 11 equals to 11, 22, 33, 44, 55, 66, 77. They're very easy before 100. 88, 99. So already you can see that we already have this number here and this number here. So the lowest common multiple of 7 and 11 is equals to 77, like this. Very simple stuff. All right. So that is a bit on that. That is a bit on that. Okay. So if you have questions, we will terminate here. Questions, feel free to ask in the comments. Don't forget to like and to subscribe, and do join us tomorrow for another. We're going to look at powers and roots. So we'll look at powers and roots tomorrow as we continue with our revision for end of term and end of year exams. Okay, so that is it. If you have any questions, please feel free to ask. Feel free to ask the questions so that we can conclude. All right. So we've been looking at this revision on numbers. We started by looking at integers, how to add and subtract integers. Then we looked at um, working with using those number pyramids where we did addition pyramids. Then we also looked at multiples, factors, and prime numbers, how to express a number as a product of its prime factors. Then we looked at how we can use that to solve problems. So let's meet tomorrow. If you've got no questions, let's meet tomorrow in our next revision on powers and roots and indices. All right. Thank you.